Hi everybody, it's Ms. Lungebach here with you today. I'll be leading you on another lesson, elements. If you don't see my video, that's all part of the plan. I'm just going to do a voice recording for this screencast. I love this topic so much because I get to grab the most beautiful photos because we are talking about our amazing Earth and the amazing universe and all of the matter that makes it up. Yesterday, we established that all matter is made of atoms, and that atoms are composed of subatomic particles, the protons, neutrons, and electrons. I would like you now, let's go ahead and add subatomic particles to our words of chemistry list on page C2. The subatomic particles are the parts that make up an atom, the protons, neutrons, and electrons. So go ahead, pause me, and add that word. Very good. Your notebook should now look a little something like this with 5 vocabulary words on page C2. So as of now, we have matter, mass, properties, atom, and subatomic particles. I've also added a cute little music video into this assignment today with a link to this video with an acronym to help you remember the subatomic particles. This video comes from STEMscopes, which you do now have access to. If the video asks you to log in, go ahead and click on STEMscopes in the waffle of your Chrome home bar, and you should have access to it there. All right. Continuing with our review, you made this table in your notebook yesterday with the properties of subatomic particles, the proton, the neutron, and the electron. The location of the proton is in the nucleus, that's the center of the atom. It has a mass of 1 atomic mass unit. It has a positive charge. It determines atomic number or element identity. That's actually what we'll talk about today. It does affect the mass and the charge. The neutron is also located in the nucleus along with those protons. It has a mass of 1 atomic mass unit, has no charge, it's neutral, that's why it's called a neutron. It does affect mass. Excess neutrons cause instability or what we call radioactive decay. And then we have the electrons. They're located in the electron cloud surrounding the nucleus. They're kind of like buzzing and swarming around the nucleus. They have basically no mass. The mass is negligible. We say it's 0, but they do have a negative charge. They control reactivity with other atoms. So we'll talk about that. And they do affect charge. They make it negative. Okay, so go ahead and complete your table from yesterday if you did not have the chance to do that in your reading. This brings us to our question for today. If all matter is made up of atoms, what causes the various forms of matter to have such different properties, whether water vapor, flame, or an animal like a human or a chameleon, or liquid water, or what makes up the universe? How can atoms take up such different properties? Well, the answer in part has to do with the periodic table of elements. There are 118 elements in the universe, each with a different identity. In each of these 118 elements, only 94 are found on Earth naturally, by the way. Each of these elements on the periodic table represents an atom with a unique combination of subatomic particles. So let's take a look at nitrogen, sulfur, and iron, for example. These are each different elements of the 118 in existence in the universe and therefore on the periodic table. What is different about nitrogen, sulfur, and iron? Let's take a look. Well, you probably noticed that they have different numbers of protons, 7, 16 versus 26, different numbers of neutrons, 7, 16, and 30, as well as electrons, 7, 16, and 26. So again, an element's unique identity is determined by the number of subatomic particles that it contains, but specifically what gives its identity, the way that we organize the periodic table, is the number of protons. The number of protons is what we use to organize each element on the periodic table. So you are going to be getting this periodic table today. It doesn't have all of the information that a regular periodic table has. It has just the name of the element. So I know this one is tiny. I have a bigger one for you, and then you'll even have this one as a PDF. But let's see here. So we took a look at that one, says nitrogen. It has a 7 above it. That's its atomic number, and that is the number of protons that nitrogen has, 7. Click back here. Nitrogen, it has 7 protons. So it's this number of protons that gives the element its atomic number or its unique identity in the periodic table. Let's take a look at sulfur right here. Sulfur, it has a symbol S in this case. It's not always the first letter of the word. We'll talk more about that later. But we do see that number 16 right there. Sulfur has 16 protons. Where's iron? Iron, that's an I. That says iodine. That's not iron. Iron's one of those tricky ones. Its element symbol is Fe. We'll talk about that later. Fe is iron, and it has 26 as its atomic number due to the fact that it has 26 protons. So today, for the very first time, I'm going to have you go through a little hunt on the periodic table, a periodic table that looks just like this. Again, that does not have all of the information that it normally does. This is like an introductory periodic table. You have a PDF of this one attached, and I'm actually going to send you into food labels today to complete an assignment called What Elements Do You Eat Each Day in Your Food? You have a Google Doc attached into this daily assignment. It looks like this. Elements in your diet. And you will fill in a table with at least 3 different food labels. If you can't find any food labels in your house, that's okay. You'll search for one like this. That's what I did. This one's for Greek yogurt. You can search for it on the internet and just get the information off of it there. But what I want you to do with those food labels is go through and to see which items on the list of the nutrition facts can you find as pure elements on your periodic table. And I give you a big hint right here. I say hint. Fats, protein, sugars, and vitamins are molecules. So you won't find those on the periodic table. Those are combinations of atoms of different elements. So we'll learn about that later. You'll fill in the table in this document. And you'll answer a couple of analysis questions at the bottom. I wanted to draw, they're just 3. I wanted to draw your attention to this third one. List the number of protons in each element that you identified. So I did give you that information of where to find that. If you recall, the number of protons is what we use to organize each element on the periodic table, and it is the atomic number. So it's that number. Let's say you had found nitrogen in your food. It has 7 protons as a review. As always, please contact your teacher with any questions that you have. And you'll be turning this assignment in to your regular classroom teacher. Thanks so much. Have fun out there.